All right, so this video is about synthetic division, which is just like long division. And it's just another tool, again, when we try to reduce polynomials in order to solve them and find out what they would equal. So when we're looking at number 7, you have to make the determination whether or not you could do synthetic division or long division. And the way you make the determination is with the divisor, okay, just to kind of throw some terms out there to you. The v minus 8, that's called my divisor. And the v to the 5th, 7v to the 4th, all that, this is what we call a dividend. This is called the dividend. Okay? And so, when we have the dividend of the divisor, no, I spelled dividend wrong. Dividend of the divisor, we're talking about the divisor. We want to focus on the divisor because the divisor will give us a clue on which method we should use. Now, when I say which methods we should use, it's not like one of them will work, one of them won't. You could actually use it for both, and it will be just fine. But I'd say if you notice these tendencies, you can, again, utilize the tools to their best capacity. So looking at v minus 8, we could do long division. There's nothing wrong with that. But what I'm looking for is, if I were to solve the divisor, if I were to actually solve v minus 8, would it come out to be a nice whole number? That's the goal of synthetic division. We want it to be nice numbers. Now, if it's a rational number like a fraction or a decimal, again, we could still do it, but it won't be as simple. So we choose to, again, only use synthetic division if the divisor, when solved, will be a nice number. So if I add 8 to both sides, v equals 8. So 8 is a nice number. 8 is a nice whole round number. So I'm going to go ahead and write that in this little box up here. And that will just remind me that is the key term I need to use when I'm doing the synthetic division. And with polynomial long division, we had to write down all the coefficients and all the variables. Here with synthetic division, we don't need the variables because if they're in order, we only need the coefficients because those are the numbers that are changing, not the variables. So there's an invisible 1 in front of v to the 5th, so I'll put a 1 in front of v to the 4th is negative 7, and then negative 5, and then negative 27, 21, and 15. And again, making sure we're aware that there's a missing variable. We had to put a 0 placeholder. For example, let's say negative 5v to the 3rd wasn't there. It just went from negative 7v to the 4th, then negative 27v squared. Make sure you put a 0 placeholder, otherwise synthetic division or polynomial long division won't work either. All right, to start the process, what you do is you bring down the very first coefficient, which in this case is 1. And then we multiply 8 times 1. Okay, so 8 times 1 equals 8. And whatever that answer is goes in the next column. And then we add these together. Negative 7 plus 8 equals 1. And then we repeat again. 8 times 1 equals 8, so we put that there. Negative 5 plus 8 gives me 3. And then repeat it again. So 8 times 3 would give me 24. Negative 27 plus 24 gives me negative 3. And then we do 8 times negative 3, which gives me negative 24. 21 minus 24 is negative 3. And then 8 times negative 3 gives me negative 24. And 15 minus 24 gives me, I believe, negative 9. Okay? And I'm done. Negative 9 is my final term there. All right, so I have now done synthetic division. Here's the cool part. Whenever we divide, we're actually knocking down the variable. So we're at v to the 5th. And if we divide it, we're not taking away one of the powers. So we go from the 5th to the 4th. So when I write my answer, I'm just going to copy the numbers that I got, 1, 1, 3, negative 3, negative 3, and just start with v to the 4th. So it's going to be 1 v to the 4th, and then plus 1 v to the 3rd, and it's plus 1 because it's a positive 1. It's going to be plus 3 because it's a positive 3, v squared, minus 3v, minus 3. And then the negative 9 is my remainder. And it doesn't go in evenly, so I just write minus 9 and divide it by the v minus 8 from the very beginning. So v minus 8. So that's how we do synthetic division, and again, it actually goes a lot faster because if it was to the fifth power we had to do polynomial long division, it would take a long time. And not that there's nothing wrong with that, but if we can have tools that are better suited to do this problem a lot faster, why not use those? So, like I said, this synthetic division doesn't work every time. I'm going to do another video, which again, we'll go through those scenarios and we'll show you how that works. But this is synthetic division.